Hello and welcome to Building an Effective Kubernetes Team in 2021. My name is Van Schubert. I take care of customers here at Giant Swarm, engage with them at a very early stage, but also throughout the whole relationship we actually have with customers. We operate Kubernetes for our customers, actually the whole cloud native stack, in a very special way. You probably already received some emails with introductions to who we are and how we operate. So I won't spend any time here on that. But if you actually are interested, you're more than welcome to reach out to me at any stage. So let's look at what we'll be covering today. And for the next, let's say, 40, 50 minutes, and then we'll have some questions at the end. So first of all, we'll actually be looking at what goals you actually have as a company to go cloud native. That's very important to figure out how to build your team to actually make you achieve these goals. Go through the different stages that companies are in. I am pretty sure that you will find yourselves in one of those rooms we typically identify as the most likely setups for companies along the cloud native journey, and then what implications you can derive from that. So it'll be interesting for me also to get your feedback. So, if you actually don't have a question, but would like to comment on something, I'll be very happy to pick that up at the end. I hope you actually enjoy it. And if you've got any questions, just ask me and I'll pick them up at the very end. So let's start off with Kubernetes teams, which is something that actually it's not the end, it's the means to an end. And I think that's where it's important to actually really understand where companies are going with the cloud native approach and why they're using Kubernetes. In many cases, from a technology perspective, it's something that needs to happen anyways, but also from a business perspective, it's very important. And I think if we actually look at Kubernetes teams, we also need to address the non-technical area. So how development teams will be using the technology, how the company can benefit from using that technology. And that's why I actually just opened up with this slide, and actually would like to introduce you to a couple of companies that I think represent how they have really managed to get a lot out of the cloud native journey. So when we look at Adidas, for example, Daniel Eichten joined Adidas in about 2012, and at that time their online business was about 40 million in revenue. And if you actually look at how that has grown to this year with 100 times growth, so they're making 4 billion in revenue through their online shop. That actually is due to their focus on cloud native and actually moving forward in that space really, really rapidly. So they actually have lots of hype sales events where they actually can also compensate for the lockdowns across the world that have happened due to the pandemic, and naturally online revenue soared tremendously in this period because it actually was the only opportunity to get live. They're expecting the biggest hype sales event in ever, I think this Saturday. So it's something that actually will be really interesting to watch. And we actually have podcasts. On the Christmas market, I think Daniel will be speaking a bit about his experiences. If you actually want to listen to Daniel, I'm pretty sure you can join this afternoon, and he'll actually be on one of the main stages in the course of the evening. Another company that I actually also wanted to highlight, which basically I see a bit from a different perspective, because we started individually on a project with them, but they then basically evolved into becoming something like the standard platform for Kubernetes for many different projects, is Vodafone. And what they actually did is they improved, and they wanted to improve customer experience or user experience by abstracting the front end away from the back end. So building cloud native technology and using cloud native technology to really leverage this. Let's say the digital channels for better customer interaction. And what they actually also wanted to make sure is that they actually had better interaction without driving the cost. So they actually needed to find a digital way to do that. So what they actually did is they developed chatbots, and we're now, especially during Corona, the Corona crisis, able to scale up these dramatically. To first of all to address the requests that surged during that period, naturally for home office and internet connections and other things, but also parts of their staff were quarantined during this pandemic, and they actually were able to keep them safe and still address customer needs and keep customers satisfied. And this scalability is something that actually has only been possible due to the cloud native technology they actually have been using to develop these chatbots. And the third one is actually also, a quite common one, which is addressing the reliability issue, which Deutsche Telekom actually had with one of their essential applications. And what they actually then decided is to move them onto Kubernetes. Luckily, they actually were already developed in Spring Boot, so they could move them, break them up a bit, and move them over onto Kubernetes. The used to be monoliths and moved them over to Kubernetes, and that actually ran quite easily within 2 weeks. I think a set of 10 applications that basically now covers essential services for the company. And and even a very funny story that we actually always tell because it's something that companies actually only appreciate if they actually have been on the cloud native journey for a while, is that they got questioned why they didn't run an upgrade that was planned, and they basically questioned why someone actually wouldn't expect the upgrade to be happening, and they actually basically found out that the people that were asking that question were monitoring the uptime and found out that it was 100% uptime. So for them in their world, that actually didn't fit together with running an upgrade and still being available 100% of the time. So this is something that was a very, very new experience. And I think these experiences you probably also share within your company, moving with Kubernetes along the cloud native path. But it actually also shows that there are customers that are at different stages of the cloud native journey, and that handle things very, very differently. So Daniel Eichten, for example, he actually built up a cloud native team. The whole company went cloud native for their online business full swing. Vodafone actually started more on a project level and then advanced to become more standard solution. And for Telecom, it actually was an individual solution and still is in that respect for a certain team. So the question is, how do you actually set up a Kubernetes team that can operate very effectively at all these different stages of the cloud native journey that these companies are in? And that's why we actually want to take a look at the different stages that we typically experience. One is basically the stage of cloud migration. That's where individual teams and developers start off going on a cloud native journey with Kubernetes. And it's typically quite easy. So you can just install it on your machine or spin up a Kubernetes cluster in one of the cloud accounts, as probably many of you already have done. And then the only area where it actually becomes a bit tricky is when it's on-prem, because then you might need to have discussions with security and firewalls and traffic and DNS and many other things where you might actually need some support in that respect, or it's getting too much for the team. But in many cases, that's not necessary. Typically in that phase, also the teams take care of certain aspects all by themselves. And then they actually operate it and keep it updated all by themselves. So that actually works quite good if you actually have individual teams. Where it becomes a bit challenging if you've got many teams. When you actually start getting the third, the fourth, the fifth team, then you actually will notice that if these teams manage and operate Kubernetes themselves, they will have a lot of repetitive work. And that's where it becomes inefficient for the whole company, naturally. And it also becomes a terrible job for developers, because they actually spend a lot of time keeping everything up to date and managing and administrating things. And that just really sucks. So that's where it actually makes sense to then think about the approach of cloud scaling, where you actually would set up a central Kubernetes team, platform team, that tries to abstract away as much as you can from the development teams, and then make sure that they still use the flexibility that the technology would provide, but at the same time, you basically try to standardize it, so you actually don't have all kinds of different versions and installations across the company, and can make any effort you put into the cloud native stack as reusable as you can across the company. So individual teams actually then don't have to manage this. This is where you have got a separation of powers, and that allows a wider scale of adoption across the organization. And then the third stage is typically achieved when you either hit a brick wall with the cloud scaling event, where you either struggle with availability, or you actually have a cost explosion because it's so successful that the whole company adopts cloud native technologies and wants to run on these clusters, or you actually have an own business model that we recently discussed with a client that basically would be facing large increase in cost for consumption for Kubernetes, licensed Kubernetes products. So this is where you might be also questioned by management if the approach is right, or if you actually have decided on a certain technology and you notice it locks you in and it's actually not longer state of the art. And that's why several vendors basically that started off on a different path switched to Kubernetes in the last couple of years. And then basically that's where a situation arises where you can make a choice of whether it's still the right path, or if you actually would like to have better influence on what components are used and where you actually invest going forward. So that's where the cloud optimization area starts. And typically companies revisit that every 2-3 years to basically rethink if their approach is still right, if their technology is right, if the cost structure fits their needs, if the operations model fits, and if the teams are supported the way they should. And that actually happens regularly. So these are basically the 3 rooms that I actually would like to kind of introduce, so we can go through them and talk about the characteristics and also the considerations that you might choose depending on where you see yourself on the cloud native journey, as they are quite distinctly different. So let's look at cloud migration, so the first room. And if you actually look at the characteristics, typically, as I already mentioned, this is where project teams take care of Kubernetes and the cloud native stack themselves. So they actually install it or spin it up in the public cloud account. They also handle a limited amount of automation for their CI/CD pipeline, maybe monitoring they just add, or they've got some security set up or whatever that they basically want to commission every time a new cluster is spun up. So that's basically where they can get rid of some manual tasks and build some automation, typically with Terraform or Ansible or whatever, and then make sure that they can basically support teams and the development quite easily. The other aspect is that we actually see a lot is customizations are typically or should be limited, because if every team takes care of that and they do a lot of customizations, most certainly something you don't want in the company. Especially if there's no reusability. But the other aspect is also quite interesting. Typically, there aren't any and not many customizations, because the projects are pretty standard, straightforward. And what you also see a lot is that they actually have less demand for high availability. And I'm talking high availability in terms of 24/7. If something goes down at night in the middle of the night, or something restarts, it doesn't matter too much. If it needs to be taken care of in the morning, that's fine. So these are projects that are actually basically would be nice to actually have them available, and that should definitely be the goal. But it's not like the core mission of Kubernetes is to keep everything up and running all the time. So that's where it actually basically makes it quite manageable for project teams. When that changes, when the availability becomes very important, and that's what I talked about with the project for Deutsche Telekom, is then it actually makes sense to think about a different approach and not have a team manage that individually, despite that teams probably can't really operate 24/7 effectively if they're at an, let's say, more modern cross-functional team level, and that's where you need to come up with a solution anyways. So what does that mean for building up your team for such a cloud migration stage? So first of all, I think the most important thing to focus on is, the goal is to support the project and get the project live quickly. So building a very complex environment is most certainly not the primary goal in this stage. It's more very pragmatic approach of bringing the project live. Something to consider, as I just mentioned, is 24/7 operations. So how do you cover that? How important is it? What does it mean in detail? If you actually run a very stable workload, and it might even be an important application, but if it actually doesn't respond within 2 hours, it may not make a difference. Then it's something that basically is something you might not be even concerned about and need to worry about. But if it actually changes, that's where you might need to find a setup that really helps and supports you. Another aspect to look out for is the unscheduled workload, especially if you actually are facing issues within your Kubernetes environment or even with your apps. Have, let's say, different team members that are at different stages in their experience with cloud native technologies. You might face downtimes or issues that you need to go in and investigate and fix, that basically it drags you away from your ordinary work. And since Kubernetes environments are typically built up by team members who enjoy playing around with new technologies, typically are also very experienced, it takes time away from those who actually could be contributing the most to whatever sets your company apart or what the goal of the application is. So it's just something to keep in mind. And if you actually see that less and less work is getting done within your project, then because of these investigations and root cause analysis, then that's something you definitely need to address and figure out how to better support such an individual project, maybe even with a fully skilled platform team. There are also naturally manual activities. As long as they stay in a bearable amount, that's fine. Maybe half an hour a week or whatever, where you need to go in, double check a couple of things, go and fix something small, then that can be resolved very easily. And the only time where it actually makes really sense to consider a different setup is these points that I just raised, but especially if the teams are growing. So if you actually look at an individual team, you might think about the first couple of points that I mentioned. But if you actually look across teams, that's where you actually see 3, 4, 5 teams doing the same job. Then actually that is definitely a point where you actually should question what are teams doing, what are they using, what are they reusing, and if that is actually very limited, then it actually might make sense to actually go and start off on the second room. That's where we come to scaling teams. The cloud scaling, the team set up for cloud scaling now. So typically that actually is either driven by a holistic approach to cloud native, with basically a whole area of technology and operations and training of the development teams and so on and so forth, driven by a CIO and basically a decision of the company to go cloud native full swing. Or even if let's say you've got different teams within the company, can be the enterprise architecture team, or it can be an infrastructure team that basically drives and sees a continuous demand for the Kubernetes technology or cloud native technology, and the support for that, where then basically people rally around and try to figure out how to best support that demand. Either it actually happens intentionally or unintentionally, like I just described at Vodafone, where basically the team used Kubernetes themselves for their project, and then that actually went so well and was set up so quickly that more and more teams knocked on their doors and asked if they actually could deploy their workloads onto these clusters. And that's where basically it actually grew and grew and grew. Now I think it's only 4% of their workload that basically runs on the clusters is from the original team, and the remaining is from other teams. So this is basically how something can evolve slowly without taking an intentional decision to do something like that. But the key challenges actually stay the same. So even if you actually grow into this role very slowly, you actually need to understand how you can support different teams. You face yourself having discussions with different departments within the organization that you basically might not be prepared for. You need to think about automation, how you can enable self-service to some extent, where you basically allow your development teams to individually spin up clusters and have them automatically pre-configured with security settings and apps that they actually want to use, if it's observability or security, and that's where you actually need to put a lot of thought into and energy into building out that automation to make sure that you basically get rid of the repetitive task, and also make sure that you don't end up with many different clusters, because then upgrade becomes a nightmare, and fixing issues is a one-off task all the time, instead of being able to deploy the fixes across the different clusters and make sure that everything stays up and running very stably. Standardization actually becomes a key element here. The teams typically would want to have certain functionality, either because it's required by software they need to install, or because the project might find a solution. Here, it's actually very challenging for individual teams to address this properly. That's why I think platform team makes most sense in this stage, that actually already has knowledge about their how to manage products. So if you actually go out and implement everything that someone asks you to do, you probably will end up with a house with 1,000 balconies. That basically brought us into the situation where we actually basically hated any change to a monolith. So the same principles actually can apply to this here too. But that's where you actually need to fully understand what the team wants to achieve and what is the best way, and especially the cloud native way, to addressing the problem. And that's where a lot of discussion typically happens with security departments, because the approach to security might be more driven by the history rather than the new possibilities of the cloud native stage. And that's where basically you need to really guide the organization and drive that forward. And you need someone who actually has experience doing this. So, actually went through the process, who actually is, excited to dive into all these details and figure out better ways to do this, to cover security, for example, or ensure governance without taking flexibility from the teams that they typically would expect if they would run Kubernetes themselves. And the final aspect here is definitely that cost allocation comes into play, especially since even if you're equipped with an initial budget for a year or 2 or 3 to build up such a platform and operate it, at some stage you'll be asked to become self-sufficient. And that's where you need to think about how to encourage first movers, because that's if they actually need to carry the whole cost at the very beginning, then it basically doesn't work as a motivator to jump onto the new platform. The other aspect is that later on, if workloads grow, you actually might end up with lots of discussions, which you can save by putting down the ground rules very clearly on who actually will be allocated with what cost, and make that very reliable, so they can plan this into their budget, and you don't end up having to cover too much of unexpected growth that the project teams might face. So here the goal is definitely to get broad adoption of cloud native technologies. So that actually should be the key driver. It's not about building the most beautiful self-service platform or developing or supporting the most extreme use cases or the weirdest configurations. This is about getting projects live and supporting them by reusing components as much as possible for different projects. You probably will also face multi-cloud environment. So every project or different project teams might have different needs. That's where you basically also need to think about reusability, especially if if your company doesn't fully commit to the cloud and a cloud provider for eternity. You actually might want to pick a more modular setup where you can basically exchange different elements very easily and quickly. And then naturally standardize that, but still leave the flexibility to development teams to configure whatever they want, but find an SRE model where basically you take up operations for the platform, but you hand back the pager if the team breaks it. So, a very mature model where, yes, you can assume operations and responsibility for something that you have developed, and give the flexibility to the teams, but the teams also need to understand that once they actually use the flexibility and they break something, then it's a shared responsibility, and everyone needs to work and fixing that. And then another important aspect is the quick win approach, I call it. I think I referred to that earlier, is instead of building a platform for the next 1.5 years, think about how you can work one project at a time, bring that onto the platform, go to the next project, and always consider the requirements that these project teams have. So you actually build something that is definitely used. We've seen it over and over again that there are plans to build self-containing environments that on paper actually look good and also very smart, but in reality basically produce a lot of cost that is unnecessarily spent because either the projects don't come or it's not necessarily needed, or it actually was, these were points raised because they actually have built their own solution that way. So, this is something definitely to watch out for and really work on an individual team basis to get them on board. I'm pretty sure that you can then also filter what projects make most sense. So a broad adoption doesn't mean 100% adoption necessarily. So if you actually have some project teams that are, basically have a certain setup, just leave them and take care of that themselves at some stage. I'm pretty sure the value discussion comes up in terms of what cost it requires to operate that, and the value that you can provide at the same time for the platform to be adopted across the company. And also, plan in resources to coordinate different projects. If you actually have a setup where you have different projects on a single cluster, this is very important, especially when there are like upgrades and breaking changes, especially. That's where you actually need to negotiate a lot between project teams when upgrades can happen. Ideally, you can circumvent it by developing a cluster for every team, but that actually doesn't make sense from a cost perspective, because then you're not efficiently using the resources you have. On the other hand, at some stage, you probably need to think about breaking out different applications into their own clusters and making sure that they basically can operate and upgrade themselves and decide themselves when they upgrade versus the effort that you actually have to put in when coordinating the upgrades to happen. So this is just something that you might want to consider, and then different customers might have different concerns in respect to upgrades. Some can actually are fine to happen automatically. Others are very concerned because the applications aren't as cloud native ready as possible as they should be to actually to sustain the upgrade. Others might be using spot instances or low priority VMs or whatever to save cost. Others might not be able to prepare the applications in a way to consume that kind of technology. So that's where you basically need to find a good segmentation of the applications and the teams into different clusters. So, and then we've got the third room, which is basically the regular revisiting of your setup and trying to find optimization. Typically here, the teams have an in-depth understanding of cloud native technologies and projects. So, there's nothing that they probably don't know. That's where, basically you typically develop larger teams who then, that basically have experts in individual areas. The setups are typically very complex, so changing that isn't easy, and there can be also quite some customization in place, especially with access to certain areas within the company, databases, storage, and so on and so forth, and that actually can make it quite challenging. And the benefit is that these teams very well know what the challenges are. So if it's actually managing service mesh, for example, then that's something they can pinpoint. They might say they don't have a problem with anything else, but this is the area that actually really keeps them up at night, and typically that's where you're looking for improvement in this area. But it's also very difficult for them to actually give up what they have been built, which is quite natural. It's also known as the IKEA effect. So, whenever you build something yourself, even if it's just screwing a chair together, you end up appreciating it nearly 100 times more than if you actually get something ready to use. So this is something just to keep in mind, that you actually, if you actually look at the companies and the teams, that you basically understand that their goal is to improve, but that basically the limitations aren't drawn, or the red lines aren't drawn nearly around the whole setup that they actually run. So encourage them to build for change. That's a very important aspect. This is a fast developing environment. Yes, Kubernetes actually has been and is developing, has become the standard, but the space is also developing very rapidly, and none of us knows what actually the market will look like in 2 to 3 years. So don't expect you to be running your setup for ages. Really understand how you can abstract different layers, so you can then basically exchange them. Also make sure that they are very modular. We just replaced our CoreOS with Flatcar, for example, this year. That's where basically CoreOS was a very promising project. Was acquired by Red Hat and then announced the end of life. So we basically had to replace that, and that just shows us that basically you need to be reinventing yourself constantly and build the application and the platform, so you can make changes very, very easily. So take out monitoring, plug in observability from somewhere else, ideally. And if technology help you do that, like a service mesh or whatever, then that might be a very good choice to do that. Also recognize the power of the community, something especially for those who have licensed products. There is open source technology out there. There is open source with a with a star, where you actually still have customization around it, which makes it very difficult to to really build that modular setup and replace certain parts in that setup. So that's where it actually becomes very important to really keep a close look at this. I talked to a company this week that basically said, yeah, we actually thought a vendor would take care of that and will make sure that the solution is future-proof. And now we actually understood, well, it's also part of our responsibility. And I think that's a responsibility of the platform team to make sure that basically you can future-proof your environment and make sure that, basically you use open source technology, because it actually just advances at a rapid pace, and it's very difficult to predict which projects will succeed and which won't. We actually see that with Istio, for example, and Linkerd, where it just seems as the community is quite frustrated about Istio not being the fully open source solution that you actually would expect for future investment. That's why they're keeping back on contributing to that project. So that's where it actually becomes important to really understand the setup and how that actually will impact the future of your technology stack. The other aspect is that typically in such a stage, you would actually be confronted with new use cases where you then need to think about co-innovation partnerships. You won't be able to solve everything yourself. We actually just have this with Adidas, for example, that they've got 21 racks in their flagship store in London, just to to manage all the interaction with the customer. This is signage systems, mirrors, videos, colors for floors, RFID, whatever. Everywhere actually have their own rack or their own blades in the racks, and building up something like this that actually doesn't necessarily have access to the internet all the time is very important in terms of security, in terms of reusability of the resources and managing it, and developing Kubernetes for such an environment. We're basically using Raspberry Pis for that, is something like, these are innovation projects where you actually have real use cases behind it, and they actually tried it out with different solutions that are already available on the market, but actually, basically found out that marketing is stronger than reality. So, that's where you actually need a trusted relationship to build that and go out and look for it. I think that's a very important aspect. Don't expect everything to basically to be provided by a single vendor. I think that's where multi-vendors make a lot of sense. And and also question what value you provide as a team to your development teams to make their lives a lot easier and increase the productivity of these teams, because that's what they're there for. Come up with innovation and drive the revenue streams, as Adidas did, going from 40 million to 4 billion. So now we actually looked at the different stages, and then just speed up a bit so we can actually go through the summary slides. So here is basically what teams or platform teams need to take care of. One is definitely in technology. You can either use upstream technology, you can use licensed products, you can also use hosted solutions. That's where you basically, that's one part of the technology, but it doesn't help you differentiate Kubernetes. There might be little, adaptations here and there, but basically there's not much difference on what Kubernetes you're using. And actually we'll be seeing a lot about that discussion happening in 2021 with cluster API becoming more broadly adopted and developed upon going forward. The other aspect is operations here. Yes, 24/7 management is important, but SLAs are important, and basically having someone who can go in and fix it. So if you actually basically have someone who basically opens a ticket and then routes that ticket onto someone, that's that's not sufficient for operations. So that's where you need to think about what do you actually expect and how can you achieve the goals, especially since it's tightly woven in between the application, the Kubernetes layer or the platform, and the underlying infrastructure, the hardware. And that's where you basically need to figure out how to best support an environment, even the SRE model that I just spoke about, where you want to give teams the flexibility, but that also means handing back the pager if they break something. And then the third aspect, which would be the evolution, that's where this is an ever-changing market. The ever-changing requirements, also use cases, and the teams are changing. So this is where you need to keep an eye on how to evolve this the stack, and also everything around it. So the DevOps tooling for the teams, CI/CD pipelines, up to predictive deployments, where you basically then help also the teams, educate them on cloud native technology, the automation around it, and evaluating new technologies constantly. That's where you need time for that. But that's where actually the differentiation comes from. So if you want to know how you can be faster than someone else in the market or one of the newcomers, then that's where it actually helps you differentiate. That's where it's really important to focus on where your platform team can help drive the efficiency of development teams and the speed of innovation within your company, and focus your platform teams on these tasks rather than others, and see if you can consume the commodity aspects from a different source. So here's basically how I would recommend the setups for the platform teams in different stages. So if you look at the cloud migration path, that's where basically the Kubernetes experts are in the project teams, but that's where I still would recommend a platform team light. That's what I would call it. So someone in the organization who actually helps. And that's cross-team, helps in containerization, but also shares the knowledge and experience between the teams, and encourages standardization. That's basically for CI/CD, monitoring, backup, security, and so on and so forth. So basically, someone who actually makes sure that basically you've got a chapter or some a chapter role who makes sure that you actually can benefit from the experience across the team, making sure that these teams work together. But that's at a very early stage where you've got single teams taking care of that. Once you actually mature more, then it's important for you to build up a platform team, and the reasons are very clear. It's driving efficiency and reusability across the organization. That's where you try to abstract as much as you can, in the technology space, operations, configuration, and so on, from the development team, so they can focus on developing what sets your company apart. And make sure that you actually drive adoption by educating development teams, making them aware of the technology, the possibilities, and also how to best develop the applications in a cloud native fashion, so they can make many upgrades and actually experience great uptime throughout the lifetime of the application. And when you actually think about cloud optimization, that's where we actually see, let's say, the standard being taken for granted, because that's actually being built up, and yes, you can always extend that, but it actually, the speciality of the teams, everyone becomes an expert in a certain area, and that can be let's say in Kafka or service mesh or observability, even like the edge use case that I just spoke about. That's where basically you've got people that actually will dive into certain areas and come up with solutions that can be reused. So this is basically, here you actually would have people who are beyond the standard Kubernetes knowledge, and actually are interested in diving into a certain area a lot deeper. And naturally, the more you actually advance, the bigger the team becomes, because if you've got different technologies, different use cases, then you actually need the different people and the knowledge about the different technologies in this space. So if you actually think about what platform teams can do to deliver the biggest value, I already talked about evolution and also parts of operations where you actually, that helps you really differentiate yourself from how fast other companies are working. But there are a couple of areas that, just to give you some ideas of where we actually see a lot of value in terms of platform teams taking care of certain elements. So one is, for example, security and governance of security, enforce configurations, automate setups, and so on and so forth. That's where basically if every team has a security discussion, then it becomes highly inefficient. That's what a platform team can do, and it actually makes it available readily to use by every development team. I'm pretty sure that most companies already have done that to some extent, that are using Kubernetes, but there's always more you can do. And there are constantly new security requirements. There help security teams understand how to develop certain things, especially if you've got a large organization and many high secure or essential applications that you haven't moved yet. I'm pretty sure you will face lots of discussions coming up because you actually will have to get clearance for certain aspects then in that course, and that's where platform teams can do a much better job. So if having someone who actually enjoys these discussion, has a lot of insight in security, is definitely a great value add to a platform team. Someone who actually takes care of developer experience, really understands how development happens and how you can best support the development team. Just give you an example of Shutterstock, which I thought was pretty cool. Is so they basically they operated Kubernetes 2 years all by themselves, and then basically asked us if we could do that for them, so they could focus on more valuable tasks. And one of these more valuable tasks was that they actually knew that there's so many different teams, and these teams deploy their applications onto different clusters, but they actually want to also make sure that that they actually can change the clusters very easily. And since they are made bad experiences in their previous setup with that, they basically developed an automation that will allow the development teams to get full control over how much traffic ends up in which cluster. So they actually could set up the old application, leave them in one cluster, and a new application in the new cluster, the same application in the new cluster, and then you can basically change the dial all by yourself as a development team on how much traffic goes where. And they basically automated that step because it actually was happening so often. And now that the development teams actually can make that change themselves and build confidence in running the application in the new cluster. And I think that's something that just shows that the trivial things that you might not even consider actually already provide a lot of benefit. They actually were then able to move between clusters a lot faster, and they actually can repetitively use that now to change the usage of clusters in a way that actually makes most sense from a cost perspective, but also from the manageability of different teams on a single cluster. Definitely encourage use of technology. I think we already covered that pleasantly. One is definitely the aspect of monitoring. So everyone builds up their monitoring so they can monitor their own workloads, but at some stage it actually becomes very apparent that with lots of microservices, you might want to go a step further and deploy observability. There are solutions out there that you can purchase, but there are also open source technologies that actually have developed quite impressively. One of our platform architects recently held a presentation on that. So if you want, go and look it up on our webinars, where he actually basically showed how observability works for open source technology with Prometheus and Grafana and Elk Stack and Linkerd as service mesh. Then think about evolving the development teams in terms of what cloud native technologies to use and how to use them. Get them on board, find blueprints on how to move old applications over very quickly, and then basically split them up from there. So this is a constant effort, and and basically that's a core requirement from our perspective for platform teams, because the stability of your platform depends very much on how good the applications are developed. So this is a constant education that basically pays into long-term success. So this is something that you definitely need to invest in, and that's often neglected. And the evolution aspect. So basically abstract different layers, make sure that you have very easily replaceable modules in your stack that you can then basically exchange at any stage if you feel that this is something that is changing very rapidly. Here's just an idea of what you can do. So either you can take care of everything yourself, the technology, the operations, evolution, the developer experience, the education of the developers. That's, basically you'd have a very, very big team then. And that's the core challenge is, how do you get these people? You can think about getting partners on board, some that just provide the technology. I think you already mentioned the license product that you may use, then some actually get technology and operations. That's where it becomes important to actually take a look at operations and how that actually helps, and then technology operations and evolution. That's where you can have support through a very basically as an extension, as an SAE team. So the SAE team basically is outsourced to a company that then basically takes care of that and works very strongly together with your development teams. And you can even think about the education and developer experience bit that you can also get consulting companies, like Container Solutions or VAD or others that basically then take care of that and help your developers at the same time to really appreciate and develop a good understanding of cloud native technologies. A couple of hints to the right on what to watch out for. Open source, I already spoke about that. Really, question how much open source, how modular everything is built up. If it supports different platforms, public cloud and private cloud. What the experience is in terms of operations. So have these companies run Kubernetes for their customers, or is it like they have built them up now and again? We've seen that several times, that consulting companies actually basically build up setups of Kubernetes, which can make sense, but basically also have a challenge that if you haven't run such an environment, it actually may look good, but you would never operate it that way. So that's where, basically watch out for that experience. Who carries the pager? So, is it you, or is it your team? Is it who hands back the pager for what? And then also, what's the upgrade strategy? So deploying upgrades automatically and manually if the team approves, that needs to happen, but they need to happen. And that's an essential part that most companies that actually go on a cloud native journey think about when they go live. And that's too late. And then, direct interaction with engineers. If you've got an issue, you want to get into a war room with engineers and not to open a ticket somewhere. And, basically, as I already spoke about, the education of development teams, that's what makes your platform very reliable. So for 2021, here are a couple of points that I consider a good outlook to think about. One is that we actually see lots of discussions around should teams be distributed, so the knowledge of Kubernetes in different teams, which definitely has a valid value, because then the teams can better appreciate the possibilities and the underlying technology. But on the other hand, that knowledge can't be shared and it doesn't scale. So that's where I would highly recommend to use a central team, and then try to basically have a SIX or something where you can special intergroups where you can exchange knowledge and experience around Kubernetes and cloud native technologies, so everyone can learn. The other thing is, DevOps. It doesn't mean doing all the ops. That's something also we've seen that, basically someone sets up the company and configures a public cloud Kubernetes account to be, for the development teams to consume themselves, but then they need to manage and run it themselves, which then basically is just contradicting anything that, basically you should be thinking about. Ops means DevOps means you run what you have built. If you haven't built it, then you don't run it. And I think that's where you actually need to really, really focus and make sure that you cut a very clear line between who's responsible for what and where you can generate the best value for your company. You actually need to think about where you can help your dev teams. I already spoke about that, so I'll skip it for now. The bimodal Kubernetes, something you might want to think about, which has to do with certain teams wanting freedom to do as much as they, and to customize it to their need, but also some that basically need a lot of help. And that's where you can easily overburden them. So think about providing different Kubernetes environments for different teams in your companies, so they can actually move forward very, very quickly. And get ready for change. Cluster API is the basically commoditization of Kubernetes, and then it actually becomes very easy for everyone to spin up clusters if it's in AKS or EKS or whatever, and then on-prem at the same time. But that actually requires you to have a very modular setup, so you can abstract like monitoring and other aspects away, so you can reuse them across platform. That's actually basically my recommendation for 2021.